European Spallation Source is a world-class multidisciplinary research centre to be built on the outskirts of Lund in the south of Sweden. Located in the cross-border region of Sweden and Denmark, in the middle of the dynamic region of Öresund, Europe will create a world centre for materials research. Öresund is literally the bridge between Scandinavia and the rest of Europe, soon to be complemented by the Fehmarn Belt link between Denmark and Germany. This will make it possible to travel on high-speed trains between Hamburg and ESS in Lund. For people travelling long distance, ESS will be located only 30 minutes away from the largest airport in Northern Europe, Copenhagen Airport, which serves over 120 direct destinations in the world. The Öresund region is the home of 3.6 million people, 12 universities, 6 science parks, 150,000 students and 14,000 researchers. ESS is located in a highly dynamic urban environment. Being the mouth of the Baltic and giving access to 8 countries, Öresund is the most densely sea-trafficked area in the world. A total redesign of the traditional seaports are underway. This gives room for new attractive living areas by the sea, with exciting architecture and venues for arts, media and culture. Science, business and culture are all dependent on each other, and investments are constantly being made with the aim of developing the Öresund region into the best place to work and live in Europe. On the site north of Lund, ESS will become a state-of-the-art technological device. The facilities built on the Lund site will constitute a world-leading European centre for materials research, giving growth. Max IV will investigate materials with synchrotron light, complementing the technique of using neutrons in ESS. A science city will be built around these 2 centres to serve the international users community. This will contribute towards ensuring the best possible scientific results. ESS can be compared to a large microscope that instead of light uses neutrons for the investigation of materials. The facility consists of 4 important sections. In the ion source, protons are generated and used to release neutrons from the target. The protons are accelerated through a linear accelerator before reaching the target station, where the separation of neutrons, the so-called spallation process, takes place. In the linear accelerator, the protons are accelerated close to the speed of light. When the protons reach the target station, they impact the atoms in the target material, which emit the neutrons. The neutrons then travel through beam guides out to the experimental stations, the so-called instruments. Here, the neutrons penetrate the material sample which is to be examined. Thanks to beam of neutrons, researchers can study sensitive samples like biological materials, which can be damaged if they're examined using X-rays. When the neutrons interact with the atoms, they are scattered, changing their direction and velocity. These changes are measured by detectors inside the instrument. With billions of neutrons giving information, the amount of data being generated is very large. ESS in Lund will transfer all this information to a high-capacity data management centre to be built in Copenhagen. From here and onwards, the ESS data will be made available for researchers throughout Europe and in the rest of the world.
We use materials when building societies. To build a sustainable society, we need to develop sustainable materials. Materials research is science for society.
ESS is going to be a wonderful instrument, really marvelous. We can see things that we today can only dream of seeing or can just see a faint shadow of. My own research is within superconductivity, so we study materials that lose all electrical resistivity below a certain temperature. As it stands today, we are not able to produce materials that would be superconducting at room temperature. But this is one of the things that we really aim to do.
Hydrogen, when you burn it, burns with oxygen and creates water. It's completely clean. What is needed is a metal substrate, we would call it, which is sufficiently porous and sufficiently light so that it can absorb hydrogen and it can desorb hydrogen and can be used as a fuel in cars or buses or possibly even aeroplanes.
In my view and the way I see the ESS, it will be a new paradigm for research facility. ESS will bring on the site top-class science, top-class scientists, and it will disseminate the results and the discovery made here to the society for better health and more efficient technology.
From my point of view, a very exciting opportunity is that our students have direct access to international modern facility where they can learn a lot of new techniques in an environment where 4,000 researchers from all over the world will come in every year, teach them new techniques and new analysis methods and the whole exchange of ideas which happens in such an environment. I think this is going to have a huge impact.
ESS will be up to 100 times brighter than its forerunners. With new knowledge of complex materials, researchers can customize new and better materials. ESS is committed to set a new international standard in terms of environmental sustainability, even when it comes to the research facility itself. The Öresund region is a remarkable environment where new ideas and innovation become reality. World-leading research within life science, clean tech and information technology is carried out here, and large international companies are located side by side with smaller innovative companies. Together with the host countries, Sweden and Denmark, ESS wholeheartedly welcomes the scientists and engineers of Europe to join in the creation of a place where science of tomorrow can become reality.
Have you heard the stories from the sand? Loving the time of science, we feed innovations around. From Copenhagen to Bilbao to Debrecen, we are joining our forces to build the souls for all mankind.